Page 2, I'm going to ask you to look this over without me. Spend some time studying what's here. I'm going to go right to the next page pretty soon, but I want you to see the steps, right? Substitution method is used to solve a system of equations by solving an equation for one variable, substituting the resulting expression into the other equation, and then go down here. Here it is. So we've got solve one equation for one variable, substitute this equation into the other equation is what it says, and solve for the variable. And once you get that variable, you plug it into the other equation. And here's an example. But I am going to go ahead and I'm going to do an example, right? So what I like to do is I like to analyze. Remember the first step. I'm going to read it off that page. It says solve one equation for one of its variables. All right? That's your notes for this, so don't lose those notes. One of these equations, in fact, both of these are really easy to solve for x. Right? I don't have to divide. All I have to do is move my y over. So they're taking this first one, and if I add 3y to both sides, I get x equals 3y plus 9. I'm going to circle that. My first step is done. Right? Solve an equation for one variable. Substitute the expression, well, in this case for x, right, into the other equation. So this is the other equation. So I'm going to take out that x and I'm going to write in 3y plus 9. Right? I substitute the equation for x. We combine like terms. That gives me 7y plus 9. Subtract 9 from both sides. That gives me 7y equals negative 7. Divide each by 7. We get y equals negative 1. There you go. Only one more step to go. Substitute the value of y back into one of the equations. Well, it doesn't matter which one I choose, but they chose this one. So if I plug in negative 1 in for y, instead of writing x minus 3 times y, we're going to say x minus 3 times negative 1. Alright, which gives me x plus 3. That's negative 3 times negative 1. If I subtract 3, I get x equals 6. Alright, so my solution is 6, negative 1. We can check the solution by graphing. Well, if I get the x-intercept here, that's 9. The y-intercept here is negative 3. So let's mark the x of, where would 9 be? Right about here. And y of negative 3 would be about here. I really need to invest in a ruler at my house. Wouldn't be too much. I get something that looks a little bit like that if I use this envelope. And this one has an x-intercept of 2. Ooh, and a y-intercept of 1/4. So 2 and about 1/4 over here. And I get something that looks like this. And sure enough, that looks to be about 6, negative 1. Alright, I graph that. Now, explain how a system in which one equation is this form, y equals c, where c is a constant, is special case for the substitution method. And I'm going to say this, right? If you already have that, step one is done, right? You don't have to do anything. You don't have to solve. It's already solved. Which is more difficult to solve? Well, I would say it's more efficient. I said solve for y because it's got no coefficient. Y because I shouldn't say no coefficient, because coefficient is 1. Alright, makes it very easy. That's it. We're going to come back. I'm going to do a couple more. We might power through after this, but that's how you do substitution. Alright, I'm going to pause this. We'll hit this page next. Nope, we got a your turn here. We're going to do one more. So right here, solve your system. And we've got this. Look how easy this one is to solve for y, right? So if I come over here, step 1, I'm going to take 3x plus y equals 14. I'm going to solve for y by subtracting 3x. y equals 14 minus 3x, or I could say negative 3x plus 14. Step 1's done. Now I'm going to take it out and I'm going to plug it into here. I'm going to plug y into this y. So step 2, watch. I'm going to write the other equation without the y. I'm going to go 2x minus 6. Y's gone. Right, I'm going to use parentheses, and in place of that y right over here, my other hand, I'm going to put 14 minus 3x. I'm going to say that equals negative 24. So we distribute through, right? 2x, negative 6 times 14 is negative 84. Negative 6 times negative 3x is positive 18x equals negative 24. So we'll combine like terms. 2x and 18x are 20x minus 84 equals negative 24. I add 84. I add 84. We get 20x equals 60. Divide by 20. X equals 3. Well, step 3, once you have an x value, plug it back into any y value. Well, I'm going to take that first one. I'm going to say 3, and instead of x, I'm going to say 3 plus y equals 14. 3 times 3 is 9 plus y equals 14. And y is going to equal 5. So I have an ordered pair of 3, 5. Done. Just a real quick mental check. I just did that, but what if I plugged it in here? That would be 6 minus 30 equals negative 24, and it works no matter which one I plug it into. Cool? There it is. I'm going to pause here. We're going to show two special cases and be finished.